Right, so remember that this is Eco 201, not Maths 201. So even though this is a maths focused course, all the tools that we are going to learn in this course are going to help us, uh, let's say, solve some economic problems or analyze economic models in a better way. So, so far we've in this course, we have only talked about matrix. So now we're going to try and solve a problem that helps us uh, analyze an economic situation. That's it. We have not done that yet. So if you're doing Eco 201, I'm expecting you guys have done at least Eco 101 and maybe even Eco 102. But notice that so far in this course, we have not talked about demand or supply or GDP or unemployment or nothing like that. So we're going to start off by doing that. And we're going to do something called a national accounting, which if you have done Eco 102, you will be very familiar with. If you haven't done Eco 101, you wouldn't really know what that is. So let me write down three formulas, or not even formulas, three relationships, which is I equal to C plus I naught plus G naught. C is equal to A plus B, Y minus T. I think the relationship we need here is that A is positive and B is within 0 and 1. And we have T equals to D plus dy. And once again, the relationship here is that D is positive and small t is between 0 and 1. So what is this? If you haven't done 1 or 2, you wouldn't really know what's going on. So let me write this down. Y is output, or you may say GDP, how much the country is producing. Or you may also call this income. C is consumption. I is investment. G is government spending. Just write government. What else? A is something that is known as autonomous consumption, which effectively means that even if our income is 0, we do not have any income, how much will our consumption be? So the consumption that is free of income. And it should be quite obvious to all of you why consumption will not be 0 if income is 0. Effectively, uh, even if you're not earning anything, you can borrow money, you can uh, dip into your savings, and at the end of the day, you're not, well, let's just say you don't want to starve to death. So even with 0 income, you have some consumption. B is something known as the marginal propensity to consume. So this basically tells us what percentage of our income we are consuming. So if your marginal propensity to consume, which is also known as the MPC, if your MPC is 0.5, that means you consume 50% of your income and you save the other 50. If your MPC is 0.8, you consume 80% of your income and you save the remaining 20. So T, the big T, is tax, how much you pay as tax. Small t is the tax rate. So if small t is 0.05, that means you pay a 5% tax on your income. And D is the lump sum tax. So think of municipal tax, for example. If you live in Dhaka city, you pay a tax of 5,000, and that's not really dependent on how much income you have. So just the fact that you live in Dhaka city means that you pay a D amount of tax, so let's say 5,000, plus you also pay a certain percentage of your income as tax. So all of this is just for you guys to understand what's going on, but mathematically, let's see how we solve this. So this is from exercise 3.5. We have not done 3.5, which is fine, but we can solve 3.5 using matrix inversion and Kramer's rule. And that is what we are doing here today. So let's part A, the question is, how many of these variables are endogenous? How many of these variables are exogenous? So let's first talk about endogeneity and exogeneity. Endogenous basically means that values that you can calculate from the model. And exogenous means that values that are determined from outside the model. So for example, if we have something like y, just show it to you guys here. So from here, you see that y, c, and t. These are the endogenous variables that we have. These are the values that we can calculate from within the model. I and g, these are values that are not given to us, that are given to us. We do not have to calculate their values. They will be given to us. So that's why they're known as exogenous. So endogenous variables, we have consumption, we have output or income, and we have government expenditure. And for exogenous variables, the values that are given to us, we have investment. Oh, no, actually, we don't have G here. We have tax, and we have G here, government expenditure. So if you have a relationship such as x squared plus 2, this could have been written as x squared plus k, where k is a constant. So this is an exogenous variable. We're not finding this from within the model. These are the endogenous variables. Okay, so let's actually come to the problem, which is we have y equals to c plus I naught plus g naught, c equals to a plus b y minus t. Let's simplify this. This becomes a plus dy minus bt. And here we have t, which is d plus dy. So what we want to do here is we want to take all the endogenous variables in one side and exogenous variables on the other side. So for example, let me just scroll up. And so here, for example, what we have here is all the endogenous variables. In this case are x1, x2, and x3. And what we have done is we have taken all of those in one side of the equation, on the left side. And whatever else is left is on the right side. So we're going to do the same thing here. So the first equation effectively becomes y minus c is equal to I naught plus G naught. The second equation becomes C minus By plus Bt equals to A. The third equation is T minus small ty is equal to D. Now the next thing we need to do is organize them. So they all have to be in the same order. So if I scroll up once again and we take a look at this expression, see the order is same in all the equations. So we have x1, then x2, then x3. In all the three expressions, that relationship holds. And that holds everywhere. Over here also, the order is x1 and then x2, x1 and then x2. So we have to maintain that relationship. So over here, we can decide on any order. So the order I want to follow is Y, C, T, which means Y will come first, then C, then T. But this can be anything. You guys can use any order that you want to use. What you just have to ensure is that you maintain that order throughout. Okay, so if I do that, this becomes, first equation is fine, Y minus C plus 0t. We do not have a value for t there. The second one will become By minus C minus Bt, By minus C minus Bt equals to minus A. And the third equation will become Ty. We do not have, we have T. So plus 0c, we do not have C here, minus 1t equals to minus D. So this is our equation 1, equation 2, and equation 3. If we convert this into the matrix form, what we are going to get is 1, minus 1, 0, E, minus 1, minus B, T, 0, minus 1. The coefficient matrix, which is YCD, and that gives us I naught plus G naught minus A minus D. And now we can solve this using matrix. We can either do matrix inversion or Cramer's rule. Since we are talking about Cramer's rule today, let's just do that. All right. So once again, we can think of this as A, X, D. So what we want to do is find the determinant of matrix A. We pick any row or any column. I'm going to pick the first row, which I usually do. And so what I get is 1 minus 0 minus minus, so plus 1 times minus B plus BT. So what I get is 1 minus B plus BT. This is the determinant of A. And now what I want to do is I want to calculate the values of Y, C, and T. So to calculate Y, C, and T, first I have to calculate AY, which will be I naught plus G naught minus A minus T. This is AY. Then we are going to construct AC, which will be And finally, we're going to construct AT, which will be G minus T. Okay. And now if we want to calculate the values, well, first we need to calculate the determinant. So let's just do that right here. So determinant AY is given by, once again, we pick any row or any column. Once again, I'm going to pick the first row, but you guys feel free to pick any row or any column. So if I'm using the first row, I have I naught plus G naught, this whole thing multiplied by 1 minus 0 plus 1. And this gives me A minus BD. Now let me just double check, make sure I have this. A minus BD, yes, that should be it. So this gives me I naught plus G naught plus A minus BD. If I calculate determinant of AC, this is AC right here. So once again, I'm going to start off with the first row. So I 1 times A minus BD minus I naught plus G naught times, let's see, minus B plus BT. So if I simplify here, I'm going to get A minus BT. Well, I'll just keep it in this form for the time being, and I'll simplify it later. And determinant of AT gives me, I'm going to use the third row this time. That seems easier. So start off with T. A minus minus, so plus I naught plus G naught minus D minus 1 minus plus B. So these are the three things that we get. So to make this a bit smaller. So if I want to find the value of y, remember according to Cramer's rule, what I have to do is ay divided by determinant of ay divided by determinant of a. So that gives me I naught plus G naught plus A minus BD divided by, how much was A? Oh, it's right there. 1 minus B plus BT. C naught is determinant of AC divided by determinant of A. So that gives me that expression A minus BD minus BT minus B I naught plus G naught. This whole thing divided by 1 minus B plus BT. And so this will actually be big T is obviously given by inverse determinant of AT divided by determinant of A. That gives us, let's see, T small t times A plus I naught plus G naught minus D B minus 1. This whole thing divided by I minus B plus BT. And so effectively what this means is that when we have this scenario, in the economy of income, output, consumption, tax, and so on, when that is represented by these three equations, we can find that the equilibrium output, the equilibrium consumption, and the equilibrium tax rate will be this. Now, if that seems a little bit confusing to you, I'm going to do a problem right now. I mean, that is going to have actual numbers. So over here we have a lot of, we have A's and D's and T's. I'm going to try and solve this problem with actual numbers, and you guys will notice that it's actually not as difficult as you're probably thinking.